EcoPath with EcoSim models the whole ecosystem. It describes a food web from primary producers to apex predators, including all the interconnected marine species, and any human exploitation. It can simulate how marine ecosystems behave and change over time and space, and the influence of a changing and varying climate, fishing, and other human activities. In short, it incorporates ecosystem-wide processes and interactions, showing how fishing and other activities impacts not only fish stocks, but the whole ecosystem, including ecosystem health and species interactions. EcoPath with EcoSim is very useful for assessing the consequences of management actions and other human activities on the entire ecosystem, and how this in turn impacts fishers. This model's strength is that it represents the whole ecosystem in great detail. It is a specialized tool to understand and mitigate human impacts on marine ecosystems. Key to the success of EcoPath with EcoSim is its flexibility. It can be easily adapted to represent any ecosystem in the world at any level of detail. EcoPath with EcoSim can be used, for example, to address ecological questions, evaluate ecosystem effects of fishing, explore management policy options, evaluate the impact and placement of marine protected areas or renewable energy, and evaluate effects of environmental changes. It is the world's most widely used marine ecosystem model, with hundreds of publications and applications to research and policy questions around the world. European examples include evaluating ecosystem-based fisheries management interventions and the impacts of climate change in all European seas, assessing the impacts of invasive species in the Mediterranean, and looking at the optimal placement of marine protected areas and renewable energy in the North Sea, among many others. While these models capture ecosystem dynamics in great detail, the models use broad assumptions about fishers' behavior and economic incentives in a fishery, and is not designed for modeling the choices made by individual fishers. Moreover, these models rely on ecological assumptions, such as species interactions, energy flows, and other ecological processes, which can be difficult to quantify and vary significantly across ecosystems. Finally, uncertainties in ecological parameters, such as predation rates or the impact of fishing on food webs, can also affect model outcomes. By combining EcoPath with EcoSim with value chain analysis and Poseidon, we will integrate human behavior and economic factors into the ecosystem models to ensure that management strategies such as quotas, subsidies, or protected areas are evaluated in terms of both ecological and socioeconomic outcomes. Moreover, integrating EcoPath with EcoSim with Poseidon and CMSY++ helps reduce ecological uncertainties by incorporating individual behaviors and stock assessment data into the ecosystem model, ensuring a more realistic representation of predator-prey human interactions. Linking EcoPath with EcoSim with system dynamics models allows for the inclusion of socioeconomic feedbacks, improving the model's ability to account for uncertainties in fishers' well-being and market prices.